Okay, today I am going to talk about recursion. It can be somewhat of a difficult topic to wrap your head around. So I'll try and do the best I can. Before we get into recursion, however, it's important to understand what happens in Java when we create objects and call methods. So I'll go over the first 2 pages of what you will find in Head First Java, Chapter 9, Life and Death of an Object. That will be great background knowledge for us when we get to recursion. So let's talk about two things, the stack and the heap, where things live. Before we can understand what really happens when you create an object, we have to step back a bit. We need to learn more about where everything lives and for how long in Java. That means we need to learn more about the stack and the heap. In Java, we care about two areas of memory. The one where objects live, the heap, and the one where method, invocations, and local variables live, the stack. So when we create an object, like with the new keyword, we're creating an object and it gets placed on the heap. So when the JVM starts up, it gets a chunk of memory from the underlying operating system and uses it to run your Java program. How much memory and whether or not you can tweak it, it depends on the version of the JVM. Okay, we know that all objects live on the garbage collectible heap, but we haven't looked at where variables live. And where variables live depend on what kind of variable it is. And by kind, we don't mean type, like primitive or object reference. The two kinds of variables whose lives we care about now are instance variables, those that are declared within an object, and local variables. Local variables are usually known as stack variables, and we'll see that stack variables live on the stack, which is a big clue for where they live. So when we create objects like new duck or duck object, button object, snowboard object, they live on the heap. When we call methods of those objects, they get put on the stack. So method, invocations, and local variables live on the stack. So we have local variables within methods or functions. They live on the stack. Instance variables and objects live on the heap. So for example, we have instance variables here. Instance variables are declared inside a class but not inside a method. So that integer size will live on the heap. And then within this method, public void vo integer x, so x, I, and boolean b, they will live on the stack. Okay, local variables. Now here's the important thing. Methods are stacked. When you call a method, the method lands on top of a call stack. That's a new thing that's actually pushed onto the stack is the stack frame, and it holds the state of the method, including which line of code is executing, and all of its variables, local variables. The method at the top of the stack is always the currently running method for that stack. For now, assume there's only one stack, but in chapter 14 they'll talk about more. So a method stays on the stack until the method hits its closing curly brace, which means the method is done. Okay, if the method foo calls method bar is stacked on top of method foo. The method on the top of the stack is always the currently executing method. So for example, we have three methods. We have public void do stuff. We assign b boolean of true, and then we call method go passing in 4. A public void go integer x. Okay, so we assign z the value of x plus 24, and then we call method crazy. Now keep in mind, neither one of these methods have finished. Neither one of those methods have hit the curly closing brace. Okay, so method void, public void calls crazy. And so method crazy just assigns to character c the value of 8, and now it reaches this its closing brace there, and then now control. So this gets pushed off the stack. Crazy gets pushed off the stack. It's no longer on the stack. And then after crazy returns, then for public void you have that closing brace there, so it reaches the closing brace. So public void is done, it gets pushed off the stack, and then once a void go returns, then public void, it reaches its closing brace, and public void gets pushed off the stack. Okay, so here we have do stuff. That was the first method, and then do stuff calls go. Go gets pushed on the stack on top of do stuff. And then go calls crazy. So crazy is at the top of the stack. It's the currently running method. When it finishes, it gets pushed off, and then we're left with go. When go gets finished, it gets pushed off the stack, and then we're left with do stuff. And then when do stuff is done, when it reaches its curly brace, it gets pushed off the stack, and then it's done. Okay, so there's some background knowledge there then, and so maybe that will help when we talk about recursion. Alright, so now let's go to an example where we don't have recursion, but you'll see how things get pushed on the stack and off. So here, let me make this a little bigger. So here I have my main method. Okay, so I'm going to assign to n the value of 0. And what I'll do initially is I'll print out, before I call this method f11, I'll print off main. And then I'm going to print n plus f1, passing in 1. Now, okay, this is going to, f1 is going to call a method, and then or this main method is going to call f1. F1 will call another method, and then that other method will call another method, and so on down the line. And then once all those methods are called, and each method has reached its curly or its closing brace, then we'll return back to main, and then you'll see finally I'll print out main again. So it's not going to print main first and then print main right away. It's going to process these methods, put them on the stack, and then when everything is done, it will print main. So let's take a look. So F1, so n comes 1 from F1, so from this call here. So F1 integer n, and now it's going to, so, and this is, I'm just illustrating as what's going to happen here. So I'll just go print out line F1, and then F1 will call F2. Okay, now this return here won't happen until F2 is done processing. Okay, so in other words, we won't return anything right away. We first have to process F2. F2, then, so n comes in, and then I'll just print out F2 to show you that I'm in F2, but then F2 is going to call F3, passing in 3. And again, we don't assign, we don't return right away. We have to get what was returned from F3 and assign it to n, and then we'll return. So these methods, they're not reaching their closing brace quite yet. And then F3, so F3 comes in, and then again I'll just print out F3, and then F4, so it will call F4 passing in 4, but again this return statement doesn't happen right away. We have to process F4. And then F4, again n comes in, and I'm just going to print out F4 to show you I'm in that function, and then F4 will call F5 passing in 5, but again the return doesn't happen right away. And then here's F5. Okay, so n comes, here's 5, and so this is integer n. It's going to pass in 5. It's going to print out 5, and then it's going to return. It's going to return 5 because that's what was passed in. It's going to return 5. So up here, when I called F5 5, so that's going to represent now 5. And then the value of n was 4, that's what was passed in, and then 4 plus 5 is 9, so it will return 9. And here F4 4, okay, so now that value is 9, and the value of n in F3 was 3, and 3 plus 9 is 12, so this method is going to return 12. Okay, so F3 3 will be 12. And so now, so this is 12, but the value of n here is 2, so 2 plus 12 is 14. So this value is going to be 14. Okay, the value of n for this method was 1, and 14 plus 1 will be 15. Okay, and so all of these methods, they're being pushed off the stack as a return statement happens or the left curly brace is reached. Okay, so then finally, so now F11 is 15 and N was initially 0. So it should print out 15. And then it will print out main. And if I run it, you see that's what happens. Well, it's already there. So you see the main and then F1, F2, F3, F4, F5. And then 15 and then main. Okay, so again, that's just demonstrating methods being put on the stack and being pushed off the stack. But they're not pushed off the stack until each method has reached its closing brace. All right, now, so I did that with 5 methods. We could just as well do that with 1 method using recursion. So recursion is just a method that calls itself. All right, so what I'm going to do, here, I'll just, actually I don't need this anymore. And I'll show you how recursion works here. But basically, we will accomplish the same thing but with 1 method, and that will be recursive sum. So initially what I'm going to do is I'm going to call recursive sum passing in 5. Okay, so let's take a look at how recursion works here then. Recursion. Okay, so if I go back here, keep in mind that the first time I call recursion sum, I'm passing in 5. Passing in 5. Okay, so here, recursion sum in 5, so I'm passing in 5. All right, and so here we go. So here I assign the sum 0, and then I check to see if n is not equal to 0, then I'm going to assign to sum n, which would be 5 for the first time through, plus recursive sum n minus 1. I'm calling itself. But keep in mind, sum is not going to be assigned right away, okay, because recursive sum n minus 1 has to process first. Okay, so if you look down here, right here, so this is recursive sum with n of 5. So sum is equal to 5 plus recursive sum 4, or 5 minus 1 is 4. Okay, so but again, sum is not going to be assigned until recursive sum 4 has finished process. All right. But then when we get to recursive sum 4, so when 4 gets passed in up here, we're going to have, again, it will say integer sum is equal to 0. If n not equal to 0, then sum equals. And so it's going to go sum equals 4, but then it's going to call recursive sum 3. Okay, but again, keep in mind that sum is not going to be assigned until recursive sum 3 is done processing. And then here, okay, so here's recursive sum 3. So again, n is 3, and now it's going to call recursive sum 2. But keep in mind, sum is not assigned until recursive sum 2 has done processing. Okay, and here's recursive sum 2 here. Recursive sum 2. So here n is 2. Now it's going to call recursive sum 1. But again, sum is not assigned until recursive sum 1 is done processing. Here's recursive sum 1. N is 1. It's going to call recursive sum 0. But again, sum is not assigned until recursive sum 0 is done processing. And so when we get to recursive sum 0, so n is going to be 0. Okay, so integer sum will be 0. If n not equal to 0, we'll call this the base case. We'll do that, but it is equal to 0. So now what's going to happen is going to print out, if you look down here, it's going to say n is equal to 0, and the sum is 0. And then it's going to return its sum, which is 0. So over here, notice it's going to return 0. It returns 0. Okay, so now that 0 value gets passed into recursive sum 1. Okay, all right, so now sum here can be assigned because recursive sum 0 is done processing. And so now we'll have 1 plus 0. That will give us 1. Okay, so now these statements will always process the system out in the return sum when sum has been assigned on this line. Okay, we'll print out these, right? So it returns sum 1, that gets returned to recursive sum 2, okay, and so now we have 2 plus 1 is 3, so recursive sum 2 is done processing, it's going to return 3. Okay, and then so it returns 3. So in recursive sum 3, then we've gotten the value that was returned from recursive sum 2, which is 3, and then 3 plus 3 is 6, so it's going to return 6. And again, every time this method, every time the recursive sum has finished processing, okay, this statement here, it drops down to the next lines. Okay, every time sum has been assigned here for each of these recursive methods, every time sum has been assigned, now we'll drop down to the next 2 lines. All right, so okay, so this was recursive sum 3, and then it received 3, and 3 plus 3 is 6, so it's going to return 6. All right, so this is recursive sum 4. Well, recursive sum 3 has processed or has returned, so it's returned 6, and so now sum will be assigned 4 plus 6, and that will be, it will return 10. And then okay, so we return 10 to recursive sum 5. Okay, so recursive sum 4 has done processing, it returns 10, and 5 plus 10 is 15. Now recursive sum 5 is finally done, okay, and it returns 15. It returns 15. So you can see the flow of what happens for each of every time the recursive sum is done processing. Okay, it prints out n is n plus n the sum is, and then return sum. All right, so you can see the flow of what's happening every time the recursive sum is done processing, or it reaches its left curly brace there. All right, and so you'll read about things like the base case, and I did this a little differently. Generally, if you look down here where I've commented out, it would generally be, this function would generally be defined like this. We would have integer sum is equal to 0, but then we would have if n equals 0, just return sum. Else will return sum is equal to n plus recursive sum n minus 1. So if n is equal to 0, return sum, we would call that the base case. All right, but I did it this way because I wanted to show you what happens every time the recursive sum is done processing. I wanted you to follow the flow of what's happening as these recursive sums get pushed on the stack, but more importantly, what happens as they get pushed off the stack. As they get pushed off the stack, sum gets assigned, and then we drop down to these lines, and then it returns the value to the preceding recursive sum. All right, so if I go back here, then, now if I run this, so you'll see, so system out print line recursive sum 5, and that's what we just saw. So if I run it, you'll see it will print out exactly what I showed you. Okay, so, but again, as I was saying, generally it would be defined this way. So if I comment this out, you'll see it process the same. So it's just not going to show everything there. Return 15, yeah. And that's what gets printed off there. System out print line recursive sum 5. All right. So yeah, so there's a overview of recursion. Somewhat difficult to understand, but very useful in certain cases. Not that we do this too much in programming, but it becomes quite important when you start working with sorting algorithms. Okay, so that's it. So that's an overview of recursion. Hope it helps.